In the early morning of September 1st, 1859, the world's most advanced technology began to spontaneously combust. Telegraph offices across North America and Europe burst into flames. Operators were thrown from their chairs by electric shocks. Papers ignited on contact with the machinery. A mysterious, invisible force was surging through the wires, a force powerful enough to burn buildings to the ground. And at the exact same time, the sky began to bleed. From Cuba to Colombia, from Hawaii to Rome, the night sky erupted in breathtaking auroras. The light was so bright that people could read newspapers outside at 1 a.m. Gold miners in the Rocky Mountains woke up and started making breakfast, thinking it was dawn. But these weren't the gentle northern lights. They were crimson red, pulsating and shimmering across the entire globe. No one knew what was happening. The planet itself seemed to be under attack. The cause of the chaos had appeared just 17 hours earlier, 100 million miles away. Richard Carrington, a wealthy amateur astronomer, was in his private observatory sketching sunspots. Suddenly, he witnessed two brilliant patches of white light erupt from the sun's surface. He described it as a white light flare, so intense it was visible even against the blinding glare of the sun. He had just become the first person in history to witness a solar flare. What Carrington saw was the muzzlefish. The flare was accompanied by a coronal mass ejection, or CME, an unimaginably vast cloud of magnetized plasma, billions of tons of the sun's own atmosphere, was ejected into space and hurled directly at Earth at over 4 million miles per hour. It was a celestial cannonball, and our planet was directly in its path. The 17-hour journey was exceptionally fast. A typical CME takes 3 to 4 days to reach us. Play animation.mov.
When this solar tsunami hit Earth's magnetic field, it induced massive electrical currents, not just in the sky, but in the ground itself. This is what fried the telegraph network. The system, which relied on long metal wires stretching for thousands of miles, became a giant antenna, absorbing the energy. In Boston, a telegraph operator reported that the auroral energy was so strong, he disconnected his battery and ran the machine for 2 hours using only the power from the sky. Here is where it gets weird. The storm's impact went beyond technology. Compasses spun wildly. Some reports claimed that the air smelled of ozone and that there was a faint crackling sound accompanying the auroras. For most people, it was a beautiful but terrifying spectacle. They had no scientific framework to understand it. Newspapers filled with speculation, blaming it on strange atmospheric conditions, volcanic dust, or divine omens. The sun itself was not yet the primary suspect. It was Richard Carrington who made the critical connection. He suspected that the flare he had observed was linked to the magnetic storm on Earth. He wrote a paper suggesting that a solar disturbance could directly impact our planet. This was a radical idea. In 1859, the sun was seen as a perfect, unchanging orb. The idea that it could be volatile and hurl energy at Earth was revolutionary. His hypothesis became the foundation of space weather science. In the 19th century, the Carrington Event was a fascinating and disruptive curiosity. The world was not yet critically dependent on electricity. The most complex technology was the telegraph, and while its disruption was serious, it didn't cause society to collapse. After a few days, the storm subsided, the telegraphs were repaired, and the event faded into a strange historical footnote. For over a century, the story ended there, a relic of a bygone era.
But this is the detail that resets the entire investigation. The 19th century mystery has become a 21st century nightmare. Our modern civilization has wrapped the planet in a delicate electronic web that is acutely vulnerable to the exact same forces unleashed in 1859. If a Carrington-level event were to happen today, it wouldn't just be an inconvenience, it would be a civilization-altering catastrophe. The historical curiosity has become an existential threat. The main vulnerability is our power grid. Long-distance, high-voltage transmission lines would act just like the telegraph wires of 1859, as giant antennas. The induced currents would flow into electrical substations, overloading and melting the giant transformers that are the backbone of the grid. Not just one or two, but potentially hundreds of them simultaneously across entire continents. The lights would go out and they wouldn't come back on for a very long time. These large transformers are not something you can buy off the shelf. They are custom built, weigh hundreds of tons, and take years to manufacture and install. A Carrington event could destroy so many at once that it would overwhelm the global manufacturing capacity. Experts estimate that widespread blackouts in some regions could last for months or even years. This is the scenario that keeps governments and power utility companies awake at night. The consequences of a long-term continental blackout are almost unthinkable. No power means no clean water pumps, no sanitation, no refrigeration for food and medicine, no banking, no GPS, and no internet. Communications would fail almost instantly. It would be a cascade of systemic failures, pushing modern society back to a pre-industrial age in a matter of hours. The 2013 Lloyd's of London report estimated the cost could be up to $2.6 trillion. Satellites would also be devastated. The intense radiation from a solar storm can fry their sensitive electronics. We could lose hundreds of satellites at once, the very machines that run our GPS, global communications, and weather forecasting. Navigating ships and planes would become incredibly difficult. The intricate orbital network that our modern world depends upon could be turned into a cloud of space junk in a matter of minutes.
This isn't just a theoretical threat. We've had several near misses. In 1989, a much smaller storm than the Carrington Event knocked out the entire power grid of Quebec for 9 hours. In July 2012, a CME of Carrington-class intensity erupted from the sun. It was one of the strongest ever measured. By sheer luck, it was aimed away from Earth. Had it occurred 1 week earlier, it would have hit us head-on. A NASA scientist stated that we would still be picking up the pieces. Scientists estimate that the probability of a Carrington-level event hitting Earth in any given decade is around 12%. It's not a question of if, but when. The sun operates on cycles of activity, and we are currently in an active phase. Space weather agencies like NOAA constantly monitor the sun, hoping to give us a few hours or at best a day's warning. But a warning can only allow us to brace for impact, not prevent it. We are living with a loaded gun pointed at our civilization. So we are left with a chilling historical lesson. A freak event from the age of steam has become a blueprint for a potential 21st century apocalypse. The same forces that gave Victorian miners a light to eat breakfast by could plunge our modern world into darkness for years. The Carrington Event reminds us that for all our technology, we live at the mercy of our star, a beautiful but volatile powerhouse that can giveth life and taketh away our civilization. The story seems complete. A massive storm in the past serves as a dire warning for the future. But this is the final unsettling detail. Recent scientific analysis suggests the Carrington Event was not a once-in-a-century storm. By studying ice cores from Greenland and Antarctica, scientists can see layers of atmospheric deposits left by major solar events. Their findings show that Carrington-level storms may happen more frequently than we thought, perhaps every 50 to 80 years.
But the ice cores revealed something far more terrifying. The Carrington Event wasn't even the biggest storm the Earth has ever faced. Deep in the historical record, both in ice cores and in the rings of ancient trees, scientists have found the chemical signature of superflares, solar storms 10 times more powerful than the 1859 event. They are so large, they defy our current understanding of solar physics. To find out what happened the last time one of these monster storms hit Earth, watch the full investigation.